Okay, so let's look at this one with fractions, okay? So with the fraction, I was suggesting that we put in multiples of the denominator. If the denominator was 3, I would have used 3, 6, 9. If the denominator was 4, I would have used 4, 8, 12. If the denominator was 5, what would I have used? If I had, let's say I had 1/5 x, what would I use for in my table of values for x? Yeah, and don't forget 0. 0, 5, 10, 15. I would use multiples of the denominator so that I can get whole numbers to graph, okay? Okay, I guess I'm going to stick with my plan that I used. No, actually, let's count 2, 4, 6. -2, -4, -6. Because I'm using those multiples in my table, so it doesn't really matter. I'm not going to use a scale of 1/2. I'm going to use a scale of 1. So, plugging in -4, I have 1/2 times -4 plus 5. And if there was more space, I did leave out the y equals because I didn't have enough room in my table. If there was more room, I would work it all out in the table. But what's half of -4? What's -2 plus 5? 3. So -4, comma 3. Okay, now we're going to do half of -2 plus 5. Half of -2 is -1. -1 plus 5 is? So -2, 4. Does everybody see where I'm getting these numbers here? Yeah? Questions? It's easier when they're positive. 1/2 times 4 plus 5. Half of 4 is 2. 2 plus 5 is 7. Okay, and I'm not going to do any further because I can see that 7, that's going to be, as far as I can go. 6 is going to be more because the slope is positive. So notice that my y values are increasing. They're getting more positive as my x values increase. So let's just plot these points then. -4, 3, -4, positive 3. Wait, did I do this right? Yeah, -4. Yes, -4, sorry. -4, 3, here we go.
I'm kind of confused.
Yes?
So you have like 2, 4, 3, but then you can switch between each. Because the value on quadrant 3 is 1 each point, right? 1, -2, or -1, -2, -3, but then on the other side it's. Oh wait, no, I'm just counting it.
Okay.
You put 3 there, so that's what's confusing me. You did 2, 4, 3.
2, 4, 6. I just counted, so I could go 1, 2, 3, 4, 5, 6. Oh, -1. 2, 4, 6. I corrected myself. Yes, you're right. That would be totally wrong. Okay. -2 and 4. That's okay. -2 and 4 is here. -2 and 4. 0, 5. What do we call this point? The y-intercept. Okay, 2, 6. 2, 6. And 4, 7. And then I'm going to go ahead and connect the points. And when we talk about slope, does anybody know what the slope is here? Again, I'm pre-talking about slope before we really know what slope is, but because we were talking about y equals mx plus b, and some of you are familiar with that, the slope is actually 1/2, which means later we'll find out more about slope, rise over run. Actually, I think in 2 days we will. The rise is 1, the run is 2. Rise of 1, run of 2. Rise of 1, run of 2. Rise of 1, run of 2. You see that? It's like stairs. Up, over, rise, run. And then we have our y-intercept of 0, 5. Here's the y-intercept, okay? Any questions on that graph? And technically I did graph all the points possible because I have a solid line with arrows on the end. So I graphed all the points, an infinite number of points. Okay, let's talk about word problems. Return of the chickens. You can tell that Ann Carey does have chickens, right? She talks a lot about chickens. Assume the initial cost of purchasing a flock of chickens and all their equipment is $400. Does that sound reasonable? Does anybody have chickens? Okay. The chicken coop, I guess. The straw, maybe some feeders. Also assume that each month they cost $20 a month to feed them, to give them new fresh straw, something like that. Let Y be the total cost of the chickens. So what did they do right here? When I say Y is the total cost of owning chickens, what is that? Yes? Yes, defining the variable. Define the variable. And they did it for you here. Let X be the number of months that you own the chickens. The total cost can be modeled. Y equals 20X, because $20 every month. That's the thing that's changing. That's what we call the variable cost, right? It varies depending on how many months you own the chickens. $400 is the flat fee. If you just purchased your flock of chickens and all the equipment, you paid $400 and you haven't even owned the chickens for any amount of time yet. That was your initial cost, your startup cost, your fixed cost. Because it doesn't vary, it doesn't change. Find ordered pairs for the solution of the equation. Then list these in table 6. So now, one thing to be aware of, a lot of times when it comes to a word problem like this, I really only want to use the first quadrant because can I own my chickens for negative months? No. Negative months is actually before I own the chickens. It doesn't work that way. So a lot of times when it comes to a word problem, we might only want to use the first quadrant where all the points are positive. You know what I'm saying? So 0 months. 20 times 0 plus 400, 0, 400, yeah? 1 month. 20 times 1 plus 400 is, 1, 420. $420 after the first month is the total that I've paid now for my chickens to own them, right? 2 months. 20 times 2 plus 400, and this would be 2, month 2, my total costs are up to $440. Does everybody see where I'm getting these numbers from? 3, 20 times 3 plus 400. In month 3, my total costs are up to $460. Okay? And we could, 4, 5, maybe 10. How much will it cost me if I own these chickens for 10 months? So every month, it's going up $20. 480, that's the slope. 5, 500. How much would it be if I owned the chickens for 10 months? Yeah, 10, 600. So now that I have these ordered pair, it doesn't really make a lot of sense for me on my y-axis to count by 1. Do you see why that is? Why I would want to change the scale on the y-axis? For the x-axis down here, we have months. And it would make sense 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 months. What kind of scale would you want to use for the y-axis so that you could actually show these points? Count by 20. And notice that's even going to be a little bit problematic. I see why you would want to use 20, but it's a tiny bit problematic because if I go 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, I still don't even have my y-intercept on here. So here's something you could do. I like the idea of the scale of 20, but I can't really, this point always has to be 0, 0. Always. If I wanted to break the graph, I could put a little break in the graph, and that's showing that I'm going from 0 to maybe my y-intercept of 400, and now count 420, 440, 460, 480, 500. You know what I'm saying? Okay. Now we can plot some of these points. 0, 400 is the y-intercept. 1, 420. 2, 440. 3, 460. 4, 5. And if I connect my points, I can always put an arrow on the end showing that it's going for infinity. This is my y-axis, which is the total cost of chickens. When we have a word problem, we don't always just want to have the x and the y-axis labeled. We also want to put, well, what are the units? What am I measuring here? So on the x-axis, the independent variable is the number of months. What depends on that is the total cost of owning the chickens. Okay, any questions about that? So again, if I break the graph, that's the only way I could avoid, if I want to use a scale of 20, that's the only way I could avoid starting my graph counting 20, 40, 60, 80. I can't do that unless I put like a little, you'll sometimes see it looks like a zigzag, or it could just be a break. Okay, and that shows that it's like, okay, we still are using a scale of 20, but I want to skip all that space. You see what I'm saying? Okay, let's look at the second word problem. Assume a new car costs $25,000 and the value diminishes $2,500 each year. Let V be the value of the car after T years. V is the value after T years. Define the variable. The value of the car can be modeled by the value is equal to, why is this a negative 2,500 times T? Decreases in value, and it starts out at 25,000. Find ordered pairs that are a solution to the equation, then list them in the table. So we always like to start with 0, because remember, you're not going to own the car for negative months unless you're Michael J. Fox and you have a time machine and you went back in time. But no, you didn't buy the car. You hadn't gotten the car yet. So how much does the car start out with in value? 0, 25,000, right? And notice this, if I wanted to do the value in thousands, I could always say value in thousands, and then I could actually have the point 0.25, and that would be an implied 0.000 on the end, right? Now, every single time I'm going to have to subtract 2,500. So 2,500, how much is the car worth in 4 years? And why would I skip ahead to 4 years? How much would you take off of the car after 4 years? For the first year, you'd take off, what's that? 10,000. So that's kind of a little bit easier, isn't it? If I say, okay, negative 2,500 times 4 plus 2,500, I'm going to be, or 25,000, sorry. After 4 years, it's going to be worth 15,000. And again, if I use that in thousands, then I don't have to use all those zeros. That's going to be convenient when it comes to graphing. How about in 8 years, you're going to take off another 10,000. So how much is the car worth in 8 years? Do you guys see kind of why I'm using, instead of using 1, 2, 3, I'm using 4 years and 8 years? Yeah? How much is the car worth then? 8 years later? 5,000. Okay, I'm just going to leave it at that. 3 points. We said we need a minimum of 3 points to graph a line. So now if we go down here, we could say, here's the value on our y-axis, and if we say in thousands, and you'll see this a lot on graphs, because I don't want to have to put in all those zeros, right? We could count up, let's see, we need to get to 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That doesn't quite get us there. What kind of scale would you want to use so that you can, we said there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 markations. So 5 thousandths? Okay, I like it. So we could even, actually look at what I could even do. I could use 2.5 and count 5, 10, 15, 20, 25. Or I could use Ashley's idea. I just kind of liked having them spread out a little bit more. And then, what should we use? What number should we use for months? Or is it months or is it years? Oh, oops, years. 4 years, 8 years. What scale do you want to use for years? Well, we could get up to 8 very easily here. 1, 2, 3, 4, 5, 6, 7, 8. What's the very first point I could plot? Yeah, 0 starts out at 25,000. I use 25 because it's in thousands. I don't have to put all those zeros on the end. Okay. 4, it dropped down to 15,000. 8, it dropped all the way down to 5,000. At a certain point, the car is going to be worth nothing. So I need 3 points at least as a minimum to form a line. Can anyone tell based on the graph at what point, value dollars in thousands, years, okay, when is the car worth $0? In other words, that would be our x-intercept. 10. You can see that right here, 10 years. After 10 years, the car is worth $0. Do you kind of see how, you don't necessarily have to do that. You can put all the zeros on here and not put in thousands, but you kind of see how it's a little bit convenient, and you will see this sometimes. That's one of the areas where I see a lot of students struggle is they don't pay attention to those little kind of shortcuts that we give ourselves to make so that we don't have such big, imagine if you started with millions. A lot of times we will do that. Like you hear people say, and you will see this in articles as well, 5.5 million instead of writing out, all those zeros after the end. You see what I'm saying? It's a similar concept. Any questions on this one?